model we can associate with the first law of Newton, also called the inertia law, because it states that the body remains at rest or uniform and rectilinear motion unless an external force acts on it. And as we will see, this model is an static system because there is no external forces acting on it. This is an static system because this is in a mechanic equilibrium. A mechanic equilibrium is when the summatory of its forces are equal to 0.
In the lab, we made an experiment that looks something like this. This is the bottle with the mass, and these two are the dynamometers. The bottle has a mass of 300 grams, and this has an angle of 45 degrees, and these two have an angle of 45 degrees. And in the plane, it looks something like this. The weight here, that is the bottle with 300 grams. And here we have the two dynamometers. This is the tension 1 and this is the tension 2. Now we have here T1x and here T2x. And here we have Y. And now we have the magnitudes, that is the angle, 45 degrees, the mass, it's 300 grams, that is equal to 0.3 kilograms. And the weight, it's mass times gravity. We have that the mass is 0.3 and the gravity 9.8, that it's equal to 2.94 newtons.
We can find the resultant force from a set of forces applied to an object by two formulas. One of them is resultant force is equal to square root of x force to square plus y force to square. So these formulas we will use in the approach.
The resultant force is equal to 0, and the formula for the resultant force is the right square of the summatory force in x to the second square plus the summatory of the force in y to the second square, and this is equal to 0. So the summatory of the forces is equal to 0, and the tension 1 in x minus the tension 2 in x is equal to 0. So the tension 1 in x is equal to the tension 2 in x.
To get the result, first we have to get the summatory of all the force in y is equal to 0. And the first one is tension 1 in y plus tension 2 in y minus weight equal to 0. So tension 1 in y plus tension 2 in y is equal to weight. So tension 1 in y plus tension 2 in y is equal to 2.94 newtons. So tension 1 is equal to tension 2, so we can substitute tension 2 in y plus tension 2 in y is equal to 2.94 newtons, and is equal to 2 tension 2 in y is y, so we use sine of the angle is 45 degrees is equal to 2.94 newtons. And we isolate this is tension 2 is equal to 2.94 newtons divided to sine of 45 degrees. Tension 2 is equal to 2.0788 newtons.
So if the tension 1 is equal to the tension 2 and the tension 2 is equal to 2.0788, the tension 1 is equal to 2.0788 newtons.
Well, now I will change the forces from Newton to dynes, and this is easier than it appears. Why? Because there is only a simple pass. The number of dynes are equals to the number of Newton multiplied by 10 elevated to the 5. Well, now I will do the substitution of this equation. The tension 1 in this case is equal to the tension 2, as you can see, and this is equal to 2.0788 newtons. Now, well, I will to multiply the 2 points per 10 to the 5 because we want to know the dynes, and this will be equal to 207,880 dynes. As you can see, this is easy, and now I have the number of dynes of the two tensions. The tension is equal to 207,880 dynes. Now I will obtain the dynes of the weight, and this will be equal the weight is equal to 2.94 newtons. Well, now 2.94 will be multiplied per 10 elevated to the 5, and I will obtain 294,000 dynes. And well, as you can see, this is easier than it appears, and well, it's okay.
Define an hypothesis is when there are two forces at the same magnitude but different direction. Tensions are equal. And if both tensions had been different, then the magnitude of the grace will be different.